Yes, team, please confirm you see my screen, my voice is audible. Thank you, sir. Thank you very much. Prometheus query language QL. That means this session is about the query browser, the bar where we used to write the queries. So what kind of queries, how can you write those queries? You have the matrix, so how can we use this query bar to analyze and to create right kind of graphs for you? So in this session, we will understand PromQL basics, operations and functions, and recording rules. This is the agenda. Prometheus has its own embedded language that facilitates querying and retrieving data from your Prometheus server, and that is PromQL. PromQL returns results as vectors. They are not scalars, they are not discrete individual values, they are vectors. What vectors? With Prometheus and PromQL, you will be dealing with two kind of vectors. First is instant vectors and second is time ranged vectors. Instant vectors will give you a representation of all the metrics tracked at the most recent timestamp, means at any one point in time, as of now, as of 5 minutes back, as of this time. That is instant, one value. Second is time ranged vectors. If you want to see the evolution of a metric over time, you can query Prometheus with custom time ranges. The result will be a vector aggregating all values recorded for a period of for the period selected. That is time ranged vectors. We'll look at some examples. Vectors. Context is we have a 8 core system which is monitored. So value of core 1 at this time, that is now, is this. Core 1 has these values. So core 1, core 2, core 3, core 4, core 5, core 6, core 7, core 8. These are all 8 cores of my computer I am monitoring. At this point in time, these are the values. So this retrieves current value. These are called instant vectors. As of now, at this time, all these 8 metrics have this value. All these 8 cores have these values. Whereas if I say range vectors, at time this core 1, this is value for core 2, this is for value for core 8, for a given last 5 minutes. First minute this was the value, second minute this was the value, third minute this was the value of these cores. So when we say last 5 minutes, we are talking about a range. So T is here last 5 minutes and this last 5 minute data. So the value of core 1 at last 5 minutes can be seen here. Value of core 2 at last 5 minutes you can see here. Value of core last 5 minutes 8, value of core 8 and last 5 minutes you can see those values. Means we are talking about the range of values for each core in last 5 minutes. So that is instant vector and range vectors. PromQL API exposes a set of functions that facilitate data manipulation for your queries. You can sort your queries, apply mathematical functions over it, and even have some forecasting functions like Holt Winters function. What are the data types in Prometheus? Prometheus uses 3 data types of matrix: scalar, instant vector, and range vector. Scalar, instant vector, and range vector. The most fundamental data type of Prometheus is the scalar, which represent a floating point value. For example, the scalars include value 0 or 18.12 or this value. All calculations on Prometheus are floating point operations. Yes. Of course. Scalar is, if I go back to one value for one core, this is one scalar value. For example, memory usage at any point in time, that will be a scalar. All right. Individual value, disk space usage will be a scalar. One point, and vector means multiple values. Yes. Over the period or the vector. Here in this case, this is value of at various cores, not one core, because we are monitoring 8 cores. So this is core 1, core 2, core 3, all cores. The difference is, I will explain this example again. The color coding is done to make you understand. This is core 1. So all these values are core 1 from point t to t.5, from 1 let's say at 10 a.m. to 10 minute 10 hour 5 minutes. So in last 5 minutes these are the different values. This blue color represent core 1. So therefore this color represent core 2. So these are ranges, and these are vectors, because vector and scalar, the difference is when we have direction and a value, we have two coordinates to represent a vector. In scalar we have only one coordinate. In this case, for example, we need two coordinate, which core you are referring to, at what time you are referring to. So therefore we are talking about vector. And when we are saying range of course, range of time, that range vectors. If I say one value at one point in time, one specific value, that is scalar. All right. Yeah. Instant vector, when you group together multiple scalars, as I said in the previous example, you asked me and I clarify that. When you group together scalars as a set of matrix in a single point in time, then you get what? You get instant vector data type. I will be quoting this example throughout my this discussion. I am talking about, we have a cycle race. So multiple cycles are participating in the race. They are of different make, different gears, and these are moving. Now let's assume that we have this scenario. We have a cycle race going on. So we want to understand what race, which make, which bike, which gears, how many gears, and after the time, I want to monitor this data. I have a lot of examples which will explain this concept of cycle race, and I will be talking about this now. The name of the metric, for example, bicycle distance meter travel. Bicycle meter distance meter total will return an instant vector, because at any one point in time the distance will be one specific value. If I change the time, the value will be different. Since metrics have both name and labels, a single name may contain many values, and that's why it is a vector, not a scalar. You got my point? Because if we are talking about multiple bicycles, we may have, yeah, exactly, vector, yeah. Whenever we have multiple values, hmm. So answer is here also. Since the matrix have both name and label, single name may contain many values, and that's why it is a vector rather than just a scalar. Scalar means atomic in nature, single value. An array of vectors over time give you a range vector. Neither Grafana nor Prometheus expression browser make graph out of range vector directly. Not possible. It is impossible to plot a graph. How can you plot a graph with a scalar value? So we need some aggregate. So neither Grafana nor Prometheus expression browser make graph out of range vector directly, but rather use instant vectors or scalars independently calculated for different point in time. Therefore, range vectors are wrapped with a function that transform it into an instant vector. For example, rate or delta or increase, rate of change or delta of change, difference of change or increase or change, that will be plotted. To get a range vector, when you query an instant vector, and append a time selector such as 5 minutes. So you specify the name of your vector. You query an instant vector. This is our instant vector, that is bicycle distance meter total. And you calculate the last 5-minute data or 1 hour data. This is example, this is 1 hour data. So this is the aggregation. So this will give you a range vector. That I am talking about range of values. I am not talking about one value at one point in time. I want to have all the possible values in last 1 hour, every 5 seconds. So give me last 1 hour data every 5 seconds and show me what was the distance, like at 10.1 p.m., 10.2 p.m., 10.3 p.m. So what was that distance travel? It will be changing, ever changing. So therefore I can plot a graph. So to plot a graph, you need to have range selection for an instant vector. So that will help you in plotting the graph. So we need this hours appended with. Labels is written after the metric name in curly braces with label equal to value. That will give you filtering or give you a more precise example. For example, bicycle distance meters total, the brand is Monarch and gear is 7. So I am talking about a 7 gear Monarch bike, and I want to calculate, I want to see the distance travel, bicycle distance meter total. Bicycle distance meters total, brand is Brompton, gear is 2. So 2 gear bike with this brand. So this will be a label selector to fetch me the specific metric for a specific brand and specific gears and a specific instant vector. And if I apply the time range after it within square bracket, that will become range vector. To get MySQL uptime as an example, I will be using in this Grafana, and that's why I'm discussing the query right now in advance. If I'm using MySQL, I want to see the uptime. So I'll say MySQL global status uptime instance is host name. I'm using this label selector to select my instance and I want to see what is the uptime. So this will be a scalar value. This will be a unique value. Similarly, if I put the square bracket and 5 minutes, so that will give me the range of values in last 5 minutes. So how the uptime is. So if it is a counter, I'll see only the counter. I'll not see the range selector. InnoDB buffer pool size. MySQL global variable InnoDB buffer pool size instance is host. That will give me InnoDB buffer pool size for my MySQL data if I'm querying it, and we'll be doing that MySQL example also in Grafana. When querying based on matrix, the same format is used. As such, bicycle distance meters total would give us the mileage of all the bikes. But if I use bicycle distance meters total, gear is 7, that would limit the resulting set to all 7 geared bicycle, not all. So we can use these operators not equal to, not matching, and matching. Matching means this should be a part of the in the name. So equal means exactly equal or not equal. Metric types. Counter and gauges are basic metric types and they store scalar. Counter always goes up, gauge can go up or down. Now the names are very conventionally used here, and I will talk about the best practices about these naming conventions, and that is a separate topic. So wait for the topic how these namings are done. So bicycle distance meters total has to be a counter. Bicycle speed meter per second is a gauge because that can change, that can go up and down. By convention, all counters end with underscore total. Then we have histograms. Histogram offers a single interface for measuring three things. One is metric name followed by count, that is metric name underscore count is the counter that stores the total number of data points. Sum is a gauge that stores the value of all data points added together. Sum can be used as a counter for all histogram where negative values are impossible. Then we have bucket is a collection of counters in which a label is used to support calculating the distribution of the values. The buckets are cumulative, so all buckets that are applicable for a value are increased by 1 on the insertion of a sample. There is a plus nf bucket, that is infinity bucket, which would hold the same value as count. Summary is another type, another is a similar to histogram, but is defined as the quantile gauge that is calculated by the client to get a higher accuracy of quantile. Functions and operation metrics can be useful by themselves, but in order to maximize their utility, some kind of manipulation is necessary, which is why Prometheus provides a number of operators and functions for manipulation of these metrics. Let's look at some of the functions. Aggregation functions or operators. The simplest form of aggregation operator would be like average. So you type AVG, within parentheses you will write your metric name, average byte speed meter per second. If you want to be able to differentiate bicycles by labels, brands and number of gears, you will be using this kind of function, average bicycle speed meter per second. Now after that you provide your filter by brand and gears. By can be replaced with without. If you want to discard a label for the new vector instead of selecting which you would like to keep, like average bicycle speed meter per second without brand or without gears. There are a number of aggregations available, the most common prominent being the hopefully self-explanatory sum, minimum, maximum and average. Like look at this, I have taken it from my real example which is coming up in Grafana, and that's why I'm explaining it right now so that you will understand it easily at that time. Max over time, we are calculating the maximum value over time. MySQL global status thread connected means total connections, maximum connections we are taking. For which instance name is host, and this is the interval. So in last 5 minutes or 10 minutes, whatever is specified by interval, or 1 hour or 1 day or whatever interval I specify, what is the maximum connections at any given interval specified here on this host. Or another example, or MySQL global status thread connected instance is host name. Some of the more complex type of functions or aggregators take additional parameters such as a top k. Top k will get you top 5, top 3, top 2. So top k 3 bicycle speed meters per second, so which gives you the overall 3 highest speeds. Top command counters in MySQL can be used, like here I will be using in Grafana top 5. Rate of MySQL global status command total and instance is hostname interval is greater than 0, or top k, I rate MySQL global status commands total instance is host and time is greater than 5 seconds or 5 minutes greater than 0. These are aggregations, aggregate functions, aggregators. Binary operators. The arithmetic operators like plus, minus, multiply, divide, modulo, that is the remainder, power, can operate on a combination of instant vectors and scalars, which can lead to a bit of word of pain if you are trying to be mathematically sound. So don't expect that you will be mathematically correct here. Let's understand how. Scalar to scalar mathematics is same as your core arithmetics, what you have learned in your basic schooling. Scalar to vector arithmetic is almost as simple. For every value in the vector, apply the calculation with the scalar. But vector to vector arithmetic is where it becomes really interesting. There's a label matching going on. And the vectors that have labels that exactly match up to each other are calculated towards each other. All other values are discarded. Take example, bicycle speed meters per second over bicycle cadence revolutions per minute. You can add an on or ignoring operators to the right of the binary operator and to limit the set of labels being used for the comparison before running it. However, all labels that are not used for the comparison are thrown away. For example, bicycle speed meters per second on gears. So I want to use this label selector. Bicycle cadence revolution per second. So I am comparing based on this label. So this will filter only geared bicycle, without gear will not be considered. If you want to keep those labels, we can keep all labels from the left hand side by adding group left after the on or ignoring keyword. In that case, the value of the right hand side will be applied on each of the left hand side labels that match the label from on. So bicycle speed meter per second on gears, group left. So this will say it will group all the left. So it will take all the values from the left hand side and only gears from the right hand side. There is also a group right, which instead of group by the right hand side values. There are also comparison like equal to, less than, not equal to, greater than, and set, and or unless operators also. Prometheus functions work much like functions in programming in general, but are limited, not very vast list of functions available, to a predefined set. Most of the Prometheus functions are approximative and extrapolate the result, which occasionally turns integer calculations into floating point values. Also means the Prometheus is really bad when exactness is required. Some usual functions are delta, increase, and rate. Each takes a range vector as input and returns an instant vector. Delta operates on gauzes and returns the difference between the start and end of the range. Increase and rate operates on counters. Increase gives the total number over time. Rate gives per second increase. For example, rate distance bicycle distance meter total last 1 hour should be same as increase bicycle distance meter per second 1 hour divided by 3600. That will be per hour, I mean 1 minute, 1 hour, sorry. Histogram quantile functions, because increase and rate have logic to handle restarts when the value is reset to 0. It's important to avoid using them with gauzes that goes up and down. That could end up looking like a restart to the function, resulting in a nonsensical value. To make sense out of the histogram bucket, we have a function called histogram quantile that take two arguments. First, the quantile that should be calculated, and second, the bucket's instant vector. Let's take an example of this. For our earlier race example, with a few more labels, this could be very interesting now. Histogram quantile 0.95 sum of race duration per second bucket by this LE. Thus would mean it will return the time in which 95 percentile racer would finish. The region we sum the finished by time is by this vector before performing the quantile calculation is because the quantile is calculated per unique combination of labels. This allows us to graph the median time per number of gears on the bike also, like histogram quantile 0.5 sum of race duration per second bucket by LE and gears. So that's how we can use some complex functions also in Prometheus query language. That's all for this session. Thank you very much, team.